Good afternoon, students. So let us start with today's class. That is, today we are discussing the last topic, waves topic. Okay. So in this waves topic, we will deal with the open end and the closed end pipes. So Doppler effect we have. So let us discuss that. And tomorrow we are discussing paper for the practice. Okay, so let us begin with the class. Here we have the first question for the today's class. Which of the following statements is incorrect during the propagation of plane progressive mechanical wave? Yes, for the plane progressive mechanical wave, which of the following statements are correct? All the particles are vibrating in the same phase. Amplitude of all the particles is equal. Particles of the medium executes SHM. Wave velocity depends upon the nature of the medium. So regarding the plane progressive mechanical wave, which is the incorrect statement they are asking. So in the given statement, all the particles are vibrating in the same phase. That is the incorrect statement for that. Okay, going for the next question. The propagation constant of a wave is also called its. So here the propagation constant K anta en barutte of a wave is also called its wavelength, frequency, amplitude, angular wave number. Yes, what is the answer here, students? So the propagation constant K, what we are introducing, what it is also called as? It is also called as option D, that is the angular wave number. Okay, so it is called as the angular wave number. Option D is the correct answer. Moving towards the next question. Yes, see the given equation is y is equal to phi sine 100 into pi t minus 0.4 pi x, where x and y are in meter. Okay, so what four statements they have given here, students? That is, the amplitude of the wave is 5 meter, the wavelength of the wave is 5 meter, the frequency of the wave is 50 hertz, The velocity of the wave is 250 hertz. So in the given option, which is the correct option, that is 1, 2, 3, all the three, or only 2 and 3, only first and fourth, all are the correct one. So if you see the solution here, see the given equation and the standard equation. If you compare the given equation with the standard equation, that is y is equal to a sine omega t minus kx is the standard equation. Okay, if I compare, a is equal to, it is pi, omega is equal to 100 into pi, k is equal to, it is 0.4 into pi. Okay, therefore the amplitude is 5 meter and the wavelength of the wave is given by 2 pi divided by k. So that is 2 pi divided by 0.4 into pi, that is nothing but the 5 meter. And the frequency of the wave is given by, it is omega upon 2 pi, that is 100 into pi divided by 2 pi. So pi will get cancelled, so the frequency will be 50 hertz. And the velocity will be v frequency into lambda. So frequency is 50 and the wavelength is 5, therefore it is 250 meter per second. Option D is the correct answer. Going towards the next question. A progressive wave is represented by, so again one more equation they are giving, and the maximum particle velocity they are asking. See, yes, can you try this one? What will be the maximum particle velocity? Again, what you need to do, first take down the equation. Y is equal to 5 into sine 100 into pi t minus 2 pi x. So copy down the equation. So if you copy down the equation, if I compare, the maximum particle velocity is given by dy by dt, which is equal to 500 into pi cos x, cos 100 into pi t minus 2 pi x. So therefore, the maximum particle velocity will be here, students, it is 500. Okay, this differentiation is given. We need to, displacement is given. You need to differentiate that to get the velocity, correct? So dy by dt agatte, when you do it dy by dt, here the coefficient of t, that is 100, is multiplied outside. So that is 100 into pi. That is 500 into pi cos agattes, because sine theta is cos theta, differentiation. You know already, correct? So if you substitute, you will get the maximum particle velocity will be 500 pi m meter per second. Yes, completed. Moving towards the next question, students. So see, again one more equation they have given. The displacement of an elastic wave is given by the function y is equal to 3 sine omega t plus cos 4 omega t, where y is in centimeter and t is in seconds. The resultant amplitude is, what will be the resultant amplitude? Yes, how you will do resultant amplitude? The resultant amplitude is given by under root of a square plus b square. So a value is 3, b value is 4. Therefore 3 square is 9, 4 square is 16. So simple, that is 5 centimeter. So ಯಾವಾಗಲೂ ಇದು ಎರಡು ರೀತಿಯಲ್ಲಿ ಇರುತ್ತೆ ಅಂದ್ರೆ equation ಕೊಟ್ಟಿರೋ equation, if you compare it with the standard equation, if it is somewhat like this, that is y is equal to a sin omega t plus b cos omega t, ಈ ತರ ಇದ್ದಾಗ we can find out the resultant amplitude by using under root of a square plus b square. So ಅದರ coefficient ಅಲ್ಲಿ just multiply square ಮಾಡ್ಕೊಂಡು root ತೆಗೆದ್ರೆ you will get the resultant amplitude. Going for the next question. The traveling harmonic wave on a string is described by y is equal to 7.5 sine of 0.005 into x plus 12t. So the equation is given. Its time period in second is. Yes, what is the answer? How you will do the time period of the given equation? Yes, see here, students. So compare the given equation with the standard equation. If you compare it with the standard equation, that is a sine kx plus omega t. So here in this, omega is equal to how much? Omega is equal to 12. So therefore the time period t is equal to, it is 2 pi divided by omega, right? So 2 pi divided by 12, that is nothing but 2 ones are 2 6s are, therefore pi by 6. So based on the waves chapter, At least one question will be there on the equations and one will be there on the other formulas. So please understand the standard equation compare ಮಾಡ್ಲಿಕ್ಕೆ ಗೊತ್ತಾದ್ರೆ you will solve the such type of questions. Okay. I'm going for the next question now. Hope so it is clear to you. See, for the traveling harmonic wave, y of xt is equal to the given equation 2 cos 2 pi into bracket 10 into t minus 0.008x plus 0.35, where x and y are in the centimeter and t is in second. The phase difference between oscillatory motion of 2 points separated by a distance of 0.5 meter is. Yes, the phase difference between the oscillatory motion. You need to calculate the phase difference between the oscillatory motion. Here the equation is given as 2 cos 2 pi 10 into t minus 0.0x plus 0.35. Okay. So here whatever outside 2 pi is given, just take it inside. So if you multiply inside 10 into 2, 20 pi t anta agate. Then 8 into 2, 16. So therefore here it is, how much it is? That is 20 pi into t minus 0.016 pi x plus 0.7 into x. Correct? So if you compare this with the given equation, that is y is equal to a cos omega t minus kx plus pi. So idru vatti compare madidre again, see, k is equal to what you can write, students? K is equal to 0.016 pi. And what about the 2 pi by lambda? The 2 pi by lambda is 0.016 into pi. So therefore lambda will be, that is 2 divided by 0.016 pi, matillu kuda pi ide. So pi will get cancelled. Therefore you will get lambda as what? Centimeter. They asked you to calculate the phase difference. So the phase difference is given by 2 pi by lambda into path difference. So first path difference is given as 0.5 meter. That will be in 50 centimeter. So therefore 2 pi by lambda, 1 by lambda is 0.08. So therefore lambda is equal to, substitute the value into the phase difference. Path difference is 50. So the correct answer is 0.8 pi radian. Let's copy down. Going for the next question, students. See, again the equation is given. Two waves are represented by the equations. Y1 is equal to a sine omega t plus kx plus 0.57 meter and y2 is equal to. The phase difference between them is. So please do it as a homework because it is similar to the previous question. Compare it with the standard equation. Okay. So y1 is equal to equation is there. Y2 is equal to equation is there. So when you are doing the phase difference, just you need to subtract pi 2 minus pi 1. 1 radian will be the answer. So do it as a homework. Copy down the question. Two waves are represented by the equation. Understanding? So based on this chapter, on the equations, it will be very simple. But equation and a standard equation compare ಮಾಡಿ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು ಯಾವ term. Yes, the phase difference between the oscillatory motion of 2 points separated by a distance of lambda by 2 is, where lambda is the wavelength. So here what they are saying, the phase difference between the oscillatory motion of 2 points separated by the distance. So the distance is given as lambda divided by 2. So what will be the phase difference? Yes, what will be the answer here? Very simple question. See how we will do. That is delta x is equal to lambda by 2. That is lambda by 2. And they have given the delta x value as lambda by 2. Okay. So therefore delta pi is equal to 2 pi by lambda into lambda by 2, which is equal to pi. So the phase difference will be pi. Because already in the previous questions, you have seen the relation between the phase difference and the path difference. So phase difference is equal to 2 pi by lambda into path difference. Correct? So therefore 2 pi by lambda into delta x irutte. So ee question alli delta x ಎಷ್ಟು ಹೇಳಿದ್ದಾರೆ lambda by 2 ಅಂತ ಹೇಳಿದ್ದಾರೆ. Therefore 2 pi by lambda into lambda by 2. Lambda lambda 2 2 cancel ಆಗಿ ನಮ್ಗೆ ಏನು ಉಳಿಯುತ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ pi ಅಂತ ಉಳಿಯುತ್ತೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? The next question, again the equation based question. So you can see how many we have the equation based questions. So if you practice these all questions, at least one question will be there on this. The equation of a wave is given by y is equal to 10 sine into bracket 2 pi by 45 into t plus alpha. If the displacement is 5 centimeter at t is equal to 0, then the total phase at t is equal to 7.5 second is. So displacement 5 centimeter iddaga t is equal to 0 irutte. Hagadre total phase at t is equal to 7.5 second is. Yes. So the given equation here, students, that is y is equal to 10 into sine 2 pi by 45 into t plus alpha. So we have written the given equation. At t is equal to 0, y is equal to 5 centimeter. Therefore, it becomes phi is equal to 10 into sine alpha. That is nothing but 1 by 2 sine alpha. So, alpha estagatte 1 by 2 sine 30, right? So, therefore, it is nothing but pi by 6. The alpha value will be how much? It is pi by 6, students. Yes. So, therefore, the total phase is given by the 2 pi by pi is equal to 2 pi by 45 into 15 by 2 plus alpha, which is equal to pi by 3 plus pi by 6. That for the total answer is pi by 2. Yes, copy down that. Let's see the next question. So here one figure they have given. It is a sinusoidal wave at a given instant. So the A, B, C, D, E points they are representing. Which points are in the phase? Which points are in the same phase? Yes, which points are in the same phase? Whether A and B, C, E, D, which one? So see here students. So in the given figure, the points C and E are in the same phase. C and E are in the same phase. Remaining all are not in the same phase anta helbodu. Okay. So that is option D is the correct answer. What is C, E? Going for the next question. So equation based. Hope so you are able to solve it. I'll move for the next question now. Yes, see this one. The wave traveling along the x-axis is described by the equation y of x comma t is equal to 0.005 sine of alpha x minus beta t. If the wavelength and the time period of the wave are 0.0 t meter and 2 seconds respectively, then alpha beta in appropriate units are. Copied on the question, we'll tell you how to solve it. Yes. Here lambda is equal to 0.08 meter, t is equal to 2 seconds, and the given equation is, compare it with the standard equation. Therefore, k is equal to 2 pi by lambda. 2 pi divided by the lambda value. Lambda is 0.08 meter. So the answer is 25 pi. But what they are asking you to calculate here, students, they are asking you then alpha beta in appropriate units are. So alpha is nothing but k, that is 25 into pi. So options ಅಲ್ಲಿ 25 into pi ಬರಿ ಒಂದೇ ಇರೋದ್ರಿಂದ directly we can choose option A. But ಕೆಲವೊಂದ್ಸಲಿ confuse ಮಾಡ್ಲಿಕ್ಕೆ they will give 25 pi in 2-3 cases. So that time the beta is equal to omega, that is 2 pi by t. So 2 pi divided by 2, which is equal to pi. Yes, all are getting the answers. See, yes, students, already you might have completed these all chapters. So when I display the question, you answer in the chat box so that you can try some questions here for your practice. See, which of the following wave function does not represent a traveling wave? Very simple question. Which is not representing the traveling wave? Yes, tell me what is the answer. Option D is, that is all are not representing, means none of the equations are representing the traveling wave. Okay. Yes. Next question, students. Again, the equation is given. The frequency of the wave is. Yes, tell me what will be the frequency. Here you know how to do such type of questions already. Just you need to compare with A sine into bracket omega t minus kx equation. So in that, the frequency, how you will do. Yes, students. So the class may end soon. Please answer because today I don't have current here. So I don't know at what anytime my laptop may shut down. Okay, please answer this. See, y is equal to 15 sine 660 pi t minus 0.02 pi x. Okay, so the reciprocal of time period will be frequency. Therefore, the frequency will be how much? It is 330. Okay, in that case, so if you are comparing with the standard equation, 1 by t is equal to how much it is? That is 330 because illi 2 pi by t anta irutte. Okay, so therefore the frequency will be 330 hertz. The frequency will be 330 hertz. The next question is, tell me this. The speed of transverse wave on a stretched string is directly proportional to the tension in the string, directly proportional to the square root of the tension, inversely proportional to tension, inversely proportional to square root of the tension. Yes, the speed of transverse wave on a stretched string is. That is option B is the correct answer here, students. It is directly proportional to the square root of the tension. The speed of the transfer wave is directly proportional to the square root of the tension. Next question, again it is a theory based question, students. A sound is produced by plucking a string in a musical instrument. Then the velocity of the wave in the string is equal to the velocity of the sound. The frequency is equal in both the case. The wave in the string is progressive. The tension in the string varies from point to point. Yes, which is the correct option? So for the musical instrument. It is option B for the musical instruments. The frequency of the wave in the string is equal to the frequency of the sound produced. ಸೊ ಹಾಗಾಗಿ ನಿಮ್ಗೆ ಅದು ಸೌಂಡ್ ಕೇಳಿಸುತ್ತೆ. ಓಕೆ, at resonance you are getting that sound waves outside. Going for the next question, students. Which of the following properties of a wave is independent of others?